This is a model of a sarcomere. On the outside is the sarcoplasmic reticulum. These black dots represent calcium ions. This is the thick filament. From the thick filament, we have myosin. This is the thin filament. The green dots represent actin. The white dots represent troponin, and these blue lines represent trypomyosin. The neuromuscular junction is located above the sarcoplasmic reticulum, where the nerve sends a message to begin muscle contraction. In order for a muscle to contract, a process called the cross-bridge cycle needs to occur, which is located in the sarcomere of skeletal muscle. When the sarcomeres of a muscle shorten, it causes the muscle to contract. This occurs when myosin forms a cross-bridge with actin. A cross-bridge begins when calcium ions bind to troponin, causing it to change shape. The calcium ions come from the sarcoplasmic reticulum, which surrounds the muscle fiber. Trypomyosin moves out of the way, exposing myosin binding sites on the actin. The myosin heads then bind to actin, which forms the cross bridge. Then, ATP attaches to myosin and is hydrolyzed to ADP and inorganic phosphate. When the inorganic phosphate detaches from the myosin head, a stronger bond between the actin and myosin is formed. After ADP is released from the myosin, something called the power stroke occurs. The power stroke causes the sarcomere to get shorter, ultimately making the muscle contract. When ATP binds to the myosin head, it detaches from actin. Once it is hydrolyzed, it splits into ADP and inorganic phosphate and goes back into its original position. Rigor mortis is when a muscle cannot stop contracting, since there is no ATP available to release the myosin from the actin. When a person dies, they cannot supply oxygen to make ATP. Rigor mortis is a result of this.